Hey friends, alright, so here's the deal. Your homework, your job tonight is to just watch this video. It's based on the note packet that you guys were given in class today. So I'm going to walk through some problems. I'm going to try to lead you towards some understanding of infinite and no solution equations, which you already have some exposure to. So your job, again, is to follow along with the video. And this should say along, not long. Let's fix that. Fill in the notes as you see them being filled in. Do the practice problems as I kind of stop and let you work on those. And then come in tomorrow ready to practice what we learned through this video. So I'm going to try to do this a couple times during the year and not just have straight up notes in class. It's going to be more of me giving you this little video, trying to give you some notes that might help you, and then you guys come in and we'll practice what you learned rather than me teaching in front of the classroom every day. So here we go. Hey guys. A quick note, I just watched the video all the way through just to see how it looked and what it sounded like, and some parts were faster than I would have liked them to. So a nice thing about YouTube is you can watch videos at higher or lower speeds. So especially in those segments where you're supposed to be practicing or writing down some notes and you want it to go a little bit slower, rather than pausing and starting and pausing and starting, you can just hit the settings button of the video in the little window of the video, choose speed, and then watch at a 0.25 or 0.5 speed. That will make the video slow down for you. Okay, so use that if you need to. Well, without further ado, let's get this thing going. Alright guys, going to start off with an equation here. Find your like terms, push them together. Again, we're working backwards from PEMDAS. So you go down to simplify, up to solve, subtract 25, divide by -4 here, you end up with 5 as your answer for G. Second equation. Okay, adding 4q to both sides, trying to get your q's together, add 11 to both sides. End up with q equals 6 after dividing off the 5. Just a little review up front with these ones. Distributing to start, getting your w's together, moving 15 by subtracting, and then you'll end up dividing by -8 here to get -2. Now, as we've talked about, checking your answer, if you throw in your answer for w, oops, let me change that to a -2. You should end up with a true statement. And that is not a -6. So let me change that really quickly. Okay, so as you check it, you should end up getting something that is equal to each other, which you're seeing there. It works. We solved correctly. And we're good. Alright, so let's start to take a look at some new stuff. Solving this equation by steps that we've learned. And x ends up being -9. Okay, so how do we know, or what do we know about this? They're only equal when x is equal to -9. If I plugged in -9, it's the only time they're going to work as far as a true statement. How can we tell? We can go back and check as we're doing here. -3 equals -3, and we're solid. Alright, so here is where we kind of go into uncharted territory, at least for what we've done this year so far. As I distribute, I see the 3x's cancel. Now we're left with -30 equals -24. And what does that do for me? So since the variables have canceled each other out, and we're left with a false statement, then we would say that these are no solutions, as you see the writing coming up now. There is no x value that will ever make these two equations, or these two expressions, I'm sorry, equal to each other. You could plug in as many values as you want. So if I plug in 1, notice that they are not equal. If I go down and plug in 2. Let's see what happens there. And how about that? They're not equal because the variables get canceled out and we have a false statement, so there's no way this will work. So a little note here, when variables cancel each other out, there's going to be one of two options, one of two things that could happen. So that's what we're going to explore with the rest of this packet. First up, no solutions, like we just saw. So there is no x value that can make the equation true or create a true statement. And this is only going to happen if the variables or x's cancel each other out when we attempt to solve the equation. And then we get a false statement. False statement means no solution. So watch as this kind of runs through a little bit. You're going to see variables cancel out with false statements, which again we conclude to be no solutions. And again, not equal at the end, the variables are gone, so that is no solutions again. So for these two, in the first one, you're going to notice that the variables again cancel out and there's no solution. But I want to show you a little contrast here between these two questions. In the second one, that does not cancel out. We end up with 6y. The constants cancel. We end up with 0 there. But we cannot say that there's no solutions. The solution itself is 0. So if you plug in 0, it's going to be a true statement. So just make sure that we're kind of seeing the difference between no solutions and 0 as a solution. Alright, so here's some practice problems that I want you guys to take a minute or two to go back and practice once we're done. So make sure you are taking a look at those in a minute. Moving on, let's see what happens if I cancel my variables and I have a true statement. What does that even mean? Well, that means that we're going to have infinite solutions. Don't worry about this top part, you can cross that off. So again, we're going to try to solve for x. If the variables cancel each other out, two options, either no solutions if there's a false statement, or a true statement would give us infinite solutions. So those are your two things that could happen. So moving forward, we're going to solve some equations and see some variables cancel out. I'm left with a true statement, so that means there are infinite solutions. Literally any x value will ever work for that problem. X's again cancel, true statement when we're done, so that again means there is infinite solutions to that problem. So again, small note here, you can test any value to check for infinite solutions. Literally anything will work. And finally, here's some more practice problems for you guys to check out and try, and so when you come in tomorrow, you're ready to practice and be successful. Last thing, locking it in with the three things that could happen when we solve a linear equation. One solution means that x is equal to something. We get a definitive x answer. No solutions and infinite solutions, as we have talked about. Variables are going to cancel, and it's either a false or a true statement. So these are the three results that we can get whenever we solve a linear equation. When you come in tomorrow, we're going to be solving a lot of linear equations and testing ourselves out with that on this particular worksheet. So you'll see that tomorrow.